Hello, algebra students. Today we're going to look at graphing quadratics again and some more examples of graphing quadratics in vertex form. So recall the vertex form of a quadratic equation. It's right here on the screen. And I didn't mention the other day, in this form, a cannot be 0. Okay, a has to be positive or negative number. If a were 0, then you wouldn't have any x at all in the equation, right? Because it would be 0 times x minus h squared. So a cannot be 0. And in this form, the ordered pair h comma k is the vertex, as we talked about. Now, we didn't mention the axis of symmetry. And we can draw that, and that's a line. And for the parabolas, it's going to be a vertical line. And the function is symmetrical around that line. So we'll see what that looks like. As we talked about, a is this thing we call the slope. It's not really a slope, but it functions something like a slope in helping us graph the function. If a is greater than 0, the parabola opens up. If a is less than 0, it opens down. So let's look at the first example. Graph this quadratic equation. And over here we have the steps. So the first step is to identify the constants. So what is the vertex of this parabola? Well, we get it from h and k, right? And I'll rewrite the vertex form here. Oh, left off the a. Okay, so h is the x-coordinate of the vertex. H again is just the thing that's subtracted there, which in this case, that's 1. 1 is subtracted, so that's h. And again, it's just positive 1 because that's what's subtracted. Okay. And the y-coordinate is k. Okay, the thing that's added, and that is 3. It's added at the end. So we've got our vertex. The axis of symmetry is just the vertical line that goes through the vertex. So that is x. It goes through the x-coordinate of the vertex. And, which also goes through the vertex. The vertical line, x equals 1. Okay, and we get it from that x-coordinate of the vertex. And that's the vertical line that goes through that. And we will graph that, and it'll make more sense when we actually draw that line. Okay. Does it open up or down? So since a is negative, it opens down. So we now have the information that we need to graph it. So first thing we do is plot the vertex. That's 1, 3, so it's right there. And then next thing is draw the axis of symmetry. And we'll draw that in a dotted line. It's vertical and it goes right through the vertex. That's the axis of symmetry. That just helps us graph it because the parabola is symmetrical around that. Okay, and now we're going to plot 2 points. Now we did this using a very quick method using this a as the slope, we called it. And that's one way to do it. Otherwise, you can also choose an x value on either side of the axis of symmetry and plug that into the quadratic to get the y value, and then plot those points, one on each side. And that's really what this A thing, the thing we do with A, accomplishes. So let's do that first, and then we'll look at plotting the points. So remember the other day we looked at A, it's -2. So we said, well, from the vertex we can go over 1 each direction and then down by 2 since it's negative in this case. And that gets us right here. And let's see, about right here. And then we go to the left also by 1 and down 2 because our A is -2. That gives us the points, and now we can plot it. We can draw the curve. And it's hard to make it good. Something like that. Oh, that's no good. And that's it. Now let's also just quickly go ahead and plot a couple points, which is the other way of finding those. That is, we will calculate the y value given the x values that we choose. So we're supposed to choose an x value, here it is, on either side of the axis of symmetry. So the axis of symmetry is this dotted line. If we go 1 to the left of that, that's 0. So we'll use x equals 0. And if we go 1 to the right of that axis of symmetry, we get x equals 2. And we could also go 2 to the left, 3 to the left, to get more points. And if you want to do a really good job and get a good graph, you would get about 3 points or so on each side, maybe 6 points altogether, and you could get a much more accurate. But we'll just do 1 on each side. So in x0, we plug that in, x equals 0. -2 times 0 minus 1 squared plus 3. That's -2 times 1, right? When we square that -1 plus 3, and that's equals 1. So that gives us the point. We plugged in 0 for 1. I'm sorry, 0 for x. And we got 1 for y. It gives us the point 0, 1. And we'll use 2. We plug that in, and that is 2 minus 1 squared plus 3. And that's -2 times 1 plus 3. And that's -2 plus 3 is 1. So that also gives us 1 for y, and this time, whoops, the x value we plugged in was 2. So we have the point 2 comma 1. So we have 0, 1, and 2, 1. And if we look at those, yeah, that's the points we already had, right? We got those same points the other method. Here we go. 0, 1 is indeed that one. I'm sorry, 0, 1 is this one. Okay. And 2 comma 1 is that one. So we get the same points, and that's because we went just 1 to the right and 1 to the left. And anytime we just do that, we will get the same points as we get from using a like the slope, because it goes just one to the right and to the left. And it works and gets a point on the graph, so it's the same point that we get when we plug in those numbers. So that's it. This technique, though, can be used to plot more points. We could also have put in x equals -1, x equals -2, and so on. And also x equals, on the other side of the axis of symmetry, 3 or 4. Okay. So that one's done. We'll look at one more. Save this. Put in the notes. And we'll look at another example. So this one says graph the quadratic equation. We'll also look at those same steps. And here we go. So what is the vertex of this one? Well, we look at, and again, I'll write down that vertex form over here. So we look for this h. Well, again, the vertex form says a minus h. That's not right. X minus h. Sorry about that. Should have caught that. Got to put the a out front. Not paying enough attention. Sorry. A goes out front. X minus h. Okay, so the thing that's subtracted from x in ours is actually -1, right? We know it's negative because the vertex form has a minus sign in there. So to take h directly from that, we have to write it in that form. If we put a minus sign, it will exactly match the vertex form, but then we wouldn't have +1 there, right? We would have -1. Okay, because that's the only way, that's what we have to do to make it equal what it's supposed to equal. It's x plus 1, but when you write it as subtraction, you'll have to say minus a -1. And then it will be x plus 1, but this way it matches the form. Okay, and once it matches the form, we can just pull the h right out of there. Since it matches the form, we can pull h right out of there, and that h is -1. Okay, so let's go ahead and write that in. And the y coordinate of the vertex is k, right? And k is the thing that's added out here. Well, what is added in ours? Well, we could say, yeah, we're adding -3, right? If you wrote it as addition, that's what it would be. So that is -3. So that's the vertex. Okay, the axis of symmetry is x equals -1. Okay, it's the vertical line that goes through that vertex, so it's going to have the same, it's going to be x equals the x coordinate of the vertex, -1. Does it open up or down? It opens up. Because a is positive. There's a right there. It's +3. Okay. So Now we plot 2 points, and that's the end. This time I think we'll just do it the easy way using A. The A is the slope. So, I didn't, actually I skipped plotting the vertex. Or did I erase it? I don't think I plotted it. -1, -3, right here. And then draw the axis of symmetry, and then we'll be ready to plot those points. And we won't choose x values on both sides of the axis of symmetry. Instead, we'll just start at our vertex, which is -1, -3. We know it opens up, and we know A is 3, right? So when we go over 1, we go up 3. 1, 2, 3, up to there. So this one's really long and skinny. That's what we expect when we get a whole number like 3 or 4, something like that. It's going to be long and skinny, because the ones we're used to looking at have A just equals probably 1 for the, usually when we look at these equations. That's the most common. So we have one of the 2 points. We went to the right by 1, and we went up 3. 1, 2, 3. The other one goes to the left 1 and goes up 1, 2, 3, and goes there. And now we can graph this. My lines are a little off. It's more like that would be it. Okay, so it's going to be pretty narrow. Parabola. Okay, so that's it. That's a couple more examples. Again, you could plot more points to get looking more accurate, but generally it's good enough to have one on each side of your vertex. So that's all for now. We'll see you soon.